All right, so I had to restart some things on my server, but let's see if this one's going to work. Yeah, so now what happens is when I send this thing up to the server, it says, hello, your number is 8. So now I have to reply. So the trick here is you need to parse that out of the string. So what I'm going to do, let's echo. If I look at my program called add, it gets something called sReceive from the server. And instead of printing it, I'm going to put that in a variable. So R equals sReceive decode. Now that's going to be a string. And now I can print response R, and then I can print some section of it, like print last character. And from what we did before, that would be R bracket -1 colon. I think that'll be just the last character. And let's see what that does. So I don't want to do this anymore. All right, let's see what that does. X, Y, enter, Python 3 add. And unfortunately, my server's getting swamped again. I'm going to have even more of these in the future. Let's see if I can hit one of the alternative ports, which is 113 and 123. Yeah, it looks like they're all swamped again. Anyway, the point is, if you get a reply, you then can pick out the number, change it to a number, and add 1 and send it back. But this one here keeps getting swamped. So you might want to just skip this challenge and do later ones and come back later when it's less popular. These services do restart periodically, but there's some limit to how many customers they can serve at a time. So let's talk about loops. Here's how you make loops for numbers and letters. So let's make this nano loop.py. All right, and so if you want to just have numbers, you can have I in range of 3, and that will count from 0 up to 1 before the end. So 0, 1, and 2. Or if you want to have letters, you can just have a character in a string, and it will count through all the characters in the string. So let's run this. Python 3 loop. All right, so that counts through numbers, and that counts through letters. But one thing that's real important is to understand whitespace in Python. I did C programming where whitespace doesn't matter, and I found this very confusing at first. If you make a loop, any kind of statement like a for loop or an if statement that applies to a block of text, you have to have a colon. That indicates that this command creates a block of text that's affected by it. Then you have to indent the next line. You can use any combination of tabs and spaces, but you must be consistent. Now, all the lines that are indented the same are in the loop, and when you stop being indented, the loop is over. So that print only applies to this one line, and if I put another statement here, like print foo, that's in the loop, and it stops being in the loop when that's over. So now it puts a foo after each one. So that's how loops and all other block statements work in Python. All right. And so now you have to have 2 numbers and then add or subtract them to find the flag here. And now we get to the part I mentioned, which was a big step forward for me in Python, learning to think of strings not as byte objects. This is a bad habit I got into from C programming. And as you may know, the huge security problems of C all come from this mainly. If you make a string in C, it's a series of bytes ending in a null byte. And the length is not stored anywhere, and you can only store one character in each byte. So you're pretty much restricted to English. And that turns out to lead to buffer overflows and a whole bunch of memory corruption attacks, because that thing is not really what a programmer would imagine they want as a string. What you really want, especially in the modern world, is you want a string to be a series of characters, and you want it to include international characters. And so a character is actually a complex object now that might require several bytes to store, and a string should be a group of those characters, not at all with a one-to-one correlation with just an array of integers, which is what C uses as strings, and that's what Python 2 uses. So that's the game here. So in Python 2, you can just put characters here, byte, 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 41, 42, FF, and then print it out as a string, and it will print the A and the B as a string, and then it'll use the \x to indicate that it doesn't know how to print the next byte as a character, and use this meta syntax to express that it's just a raw byte. But you can refer to it as A2, and it will have the one byte in there. And I was used to doing this. You can do this in C also, but it really doesn't make a lot of sense. And if you try doing that in Python 3, you're going to get weird results. One thing that's really bizarre is that the third character that I set, let me do this one live. If I set up, we're going to bring up Python 3, and I set this stuff here. Okay, this is going to define a string as a series of 3 bytes, and the third byte is just some strange foreign character, Y umlaut, but it's lying. If I look at the actual bytes that were created here, all right, didn't copy, all right. There, the actual last byte was BF. Even though I put an FF there, it turned into a BF. So what is going on here? It's turned into 2 characters, C3BF, because FF is not a valid Unicode byte, and Python 3 uses Unicode. Now, if you use Microsoft operating system, they use a really old version of Unicode where you only have 2 bytes per character. And it's really inefficient and kind of messed up, because even 2 bytes is not enough for all the international characters you might want these days. And it means that all the normal English strings are double sized. They have an extra null byte after each ASCII character. But that was an early version of Unicode, and Microsoft made it their standard. But Python 3 uses a more modern version of Unicode called UTF-8. And UTF-8 is sort of like the IP version 4 address system. It can use from 1 to 4 bytes, and these are things are called code points, and the first byte tells you which one you're using. So a single FF is not a valid symbol in Unicode, because the FF would be down here, be one of these ones that should be longer, so it expects 3 more bytes after it. So anyway, that's the game here. So now you can try to print out various values to see what these Unicode characters do. All right. And so here, this one, \x41 is an A, but \u, which is Unicode 41, is not okay. Because if you're going to use the \u, it expects more bytes than that. So you can't have 1, 2, or 3 bytes. If you're going to use this \u notation, you must express it as all 4 bytes, and now you get a capital A. Not that it is stored in 4 bytes. It is, these things are called Unicode code points. It is code point 41. And there are 1 million code points defined, and those are the real characters. So that's more madness. And so there are various ways to encode and decode, but this you get used to, and after you get used to it, it makes a lot of sense. This is what characters are. A character is a more complex object. All right, and so now you can find all kinds of special characters like a sigma and a hamburger. There's all emoticons are also just Unicode code points, and you can put them in Python now. You just have to get over the mindset that a list of characters in Unicode maps to a list of bytes. It doesn't, not in a simple way. All right, I'll stop this one.